Group 2. Atomic radius. Atomic radius increases down the group because of increase in shells with electrons in them, which makes the atom larger. Melting points. Melting point decreases down group. Metallic bonding weakens as atomic size increases. Distance between positive ion and delocalized electron increases. So electrostatic attraction between positive ions and delocalized electrons weaken. First, ionisation energy. Outer electrons are held weakly because they're further from the nucleus. And outer shell electrons become more shielded from attraction of nucleus by repulsive forces of inner shell electrons. Group 2 reactions with oxygen. Reactivity of group 2 metals increases down group. Magnesium reacts slowly in oxygen without flame. Magnesium normally is coated with magnesium oxide as it reacts with oxygen in the air. Magnesium oxide needs to be removed, and to do this use sandpaper. If you're testing for reaction rate between magnesium and an acid, then you could get a false result if your magnesium is not clean because magnesium and magnesium oxide react by at a different rate. Magnesium and hydrochloric acid would form magnesium chloride and hydrogen. Magnesium oxide and hydrochloric acid form magnesium chloride and water. Group 2 metals burn with oxygen and magnesium burns with bright white flame, and white power of magnesium oxide is formed. Magnesium oxide is white solid with a high melting point because it's ionic. Group 2 reactions with water. Magnesium reacts with steam to make magnesium oxide and hydrogen. Magnesium would burn with bright white flame and white powder of magnesium oxide forms. So, magnesium and water forms magnesium oxide. And hydrogen. Magnesium reacts with warm water, so there's a different magnesium hydroxide product formed. So, it's magnesium and water which forms magnesium hydroxide and hydrogen. This is a slower reaction than reaction with steam, and there's no flame. Other group metals react with cold water, and the reactions get more insane down the group, and they also make hydroxides and hydrogen. Hydroxides can dissolve in water to form alkali solution. Observations are fizzing, metal dissolving, solution heating up, and calcium produces precipitate, and about of precipitate form decreases down the group. Magnesium's use in extracting titanium. Titanium is abundant, has a low density, and corrosion resistant, so used to make strong light alloys for aircraft. Titanium can't be extracted with carbon because titanium carbide will form, and not titanium, and can't be extracted by electrolysis because it would have to be pure. Titanium is extracted by reaction with more reactive metal like magnesium. Titanium's expensive because of high cost of magnesium, batch process so expensive because process is slow and needs more labor and energy lost. When reactor is cooled down after stopping, argon needed and need to remove moisture because titanium chloride may do hydrolysis and high temperature needed. Titanium oxide is converted to titanium chloride so it can be purified by fractional distillation because titanium chloride is molecular so liquid at room temperature and not ionic like titanium oxide, which is solid at room temperature. Steps of titanium extraction. 1. Titanium oxide is converted to titanium chloride at 900 degrees. Titanium oxide and chlorine and carbon forms carbon monoxide and titanium chloride. 2. Titanium chloride purified by fractional distillation in argon atmosphere. 3. Titanium extracted by magnesium in argon atmosphere at 500 degrees. Titanium chloride and magnesium forms titanium and magnesium chloride. Calcium oxide. Calcium oxide used to remove sulfur dioxide from waste gases in furnace by flue gas desulfurization. Gas passes through scrubber, which has basic calcium oxide, which reacts with acidic sulfur dioxide in neutralization reaction. Sulfur dioxide and calcium oxide forms calcium sulfite. Calcium sulfite used to make calcium sulfate for plasterboards. Solubility of hydroxides. Group 2 hydroxides become more soluble down the group. All group 2 hydroxides, when they're not soluble, are a white precipitate. Magnesium hydroxide is insoluble in water. Simplest ionic equation for formation of magnesium hydroxide is magnesium ions and hydroxide ions. Magnesium hydroxide in water means it's slightly alkali, so some hydroxide ions are made by dissolving it. Magnesium hydroxide used in medicine to neutralize excess acid in stomach and to treat constipation. So, magnesium hydroxide and hydrochloric acid produce magnesium chloride and water. Safe because it's insoluble, meaning it is weakly alkaline, so not corrosive. Magnesium hydroxide preferable to using calcium carbonate when treating excess stomach acid, as it will not make carbon dioxide gas. Calcium hydroxide is partially soluble in water and appear as white precipitate. Solubility of sulfates. Group 2 sulfate become less soluble down group, and barium sulfate is least soluble. Formation of precipitate can be in full or ionic equation. Barium sulfate is used in medicine as barium meals given to patients who need X-rays of their intestines. Barium absorbs X-rays, so gut shows on X-ray image. Barium compounds are toxic, but it's safe to use because barium sulfate has low solubility, so not absorbed in blood. Barium metals reacted with sulfuric acid slowly because insoluble barium sulfate produced covers surface of the metal, and so it's a barrier to other attacks. Same thing happens but less up the group, but it doesn't happen with other acids like hydrochloric acid and nitric acid because they make soluble salts. Testing for sulfate ions. Barium chloride solution is acidified using hydrochloric acid as a reagent too. Test for sulfate ions. Acidified chloride added to solution that has sulfate ions, a white precipitate of barium sulfate forms. So, barium ions and sulfate ions react to form barium sulfate. Hydrochloric acid is used to react with carbonate impurities that are in salts, which would form white barium carbonate precipitate and give false result. Don't use sulfuric acid because it has sulfate ions and would give a false positive. Fizzing because of carbon dioxide is seen as hydrochloric acid and sodium carbonate form sodium chloride and water and carbon dioxide. Insoluble salts and precipitation reactions. Insoluble salts made by mixing solution of ions, so precipitate is formed. Barium nitrate and sodium sulfate, which forms barium sulfate and sodium nitrate. They're called precipitation reactions. Precipitate is solid. Make insoluble salt. Normally salt would be removed by filtration, wash with distilled water to remove soluble impurities and then dried on filter paper. Filtration. Draw filter paper. There is 2 types of filtration. Type 1, which have filter funnel that has filter paper, which allows residue to be collected, and in the beaker the filtrate is in. Type 2 is Buchner flask, and then place Buchner funnel and add filter paper in it. On Buchner flask, they're an air outlet to water pump. Ionic equation writes up. Spectator ions are ions that are not changing state and not changing oxidation. Number 1. Take full equation. 2. Separate aqueous solutions into ions. 3. Cancel out spectator ions, leaving simplest ionic equation.